Hi guys, this is Mrs. Hoover starting Unit 11 with kinetics and equilibrium. Kinetics, if you remember, kinetic energy versus potential energy. Is kinetic the one where the ball is on top of the hill or the one where it is rolling down? And if you remember correctly, it's the one where it's rolling, right? Potential is when it's on top of the hill with potential, but it's not moving. Kinetic is the one where it's actually moving, okay? So we want to think of kinetics as like motion, right? So in this unit, we're going to talk about the motion of particles, how they come together to actually do a chemical reaction, right? So the motion of particles in a chemical reaction. And then equilibrium is talking about like the equaling out between particles in a reaction. All right, so let me erase that. Okay, now back to scroll down, sorry. So we have some notes here. And one big thing you have to know is that kinetics, we're going to talk about the speed of chemical reactions. And instead of calling it speed all throughout this unit, we're going to use the word rate. Like if you'd say toilet paper is being used at an extremely fast rate right now, right? Rate means like speed, okay? So you got to get used to the word rate meaning speed because we're going to talk about reaction rate a lot. And whenever we do, I want you to think reaction speed. We'll also talk about the reaction mechanism, like how it occurs, but that one's not quite as important. All right, scrolling down. The reaction mechanism is the path that it takes. When I looked through Regents questions, when I was really trying to narrow it down for you guys since you're learning at home, I didn't really see much about that, so we're just going to move on. Big thing we're going to talk about is collision theory, okay? Collision theory is the fact that what is a collision, right? A car collision is when two cars collide, right? So collision theory is about particles colliding. And all this theory says is that for chemicals to react, they have to collide. They have to actually hit each other. So you can't just have like one chemical in this bottle and one chemical in this bottle and they just react, right? You have to actually pour the chemicals from here to here. There are some where like the vapors, like the gas can go from here to here and they can be dangerous. But most of the time you have to actually mix things to get them to react, right? You would put two things in one beaker if you wanted them to react. So one of the rules is just that in order for a reaction to happen, the particles have to collide. You got to get them together. And we call that when they collide, we call that an effective collision. And there's two rules for being an effective collision, right? So for those, I like to think of like, what would you need to do to hit a home run in baseball? All right. So you have to hit the ball. It's my bat. You have to hit the ball with like, you have to hit it hard enough, right? It has to be like a really nice hard shot in baseball, right? So that's one part of being an effective collision is that you have to hit it hard enough, okay? The particles can't just kind of like come together and like boop. Okay, you want them a nice hard collision to get a good reaction. That's why like sometimes stirring chemicals helps them to react faster because you're like helping them to collide better. The other thing is that you want to think about hitting a home run. You don't want to hit under the ball because the ball goes up. You don't want to chop it too much on top of the ball because the ball goes down. Boom, boom, down. You want to hit it like a really nice orientation, right? You want to hit like a nice home run. You're going to hit it solid, right? So that's the other part is that you want the particles to hit with a solid collision, right? So you want to have the correct orientation. So that's really it for collision theory. The theory says that in order for reactants to react, they have to collide. That collision has to be effective. And the two things to be effective are one, enough energy, and two, the right orientation. All right. And you will find a lot of questions about that in your CASEL learning. All right. And then in the next video, we'll talk about 5 ways to speed up a chemical reaction. Before you watch that, I'm going to ask you to watch this really awesome TED Ed. It is not a filler. It is really, really good. All right. So I'll see you in our next video. Thanks for watching.